Hello, math students. Welcome back to our module on linear equations. This is lesson 21, and it is called Some Facts About Graphs of Linear Equations in Two Variables. Our goal for today is we will learn how to identify the linear equation based on points on a line. The question that I want you to think about in this lesson is, what must you have to create an accurate equation of a given line? All right, so we're talking about some things in the things to know section, and the first thing that it asks us to do is, what is the equation? And the information that they give us is a line goes through a point at 5, -7, and it has a slope of -3. What is the equation of the line? So in order for us to figure out what the equation of the line is, there are many different ways that we can do that. You can do that by graphing it, plotting that one point on there and then applying the slope to it and finding out where it would cross at the y-axis and then determining your equation that way. Or you can use the information that you're given. Instead of having to draw the graph, you can use the information that you're given by applying it to the equation parts that you know. So in the previous lesson, we talked about the importance of understanding all of the different parts of both the equations of standard form and slope-intercept form. And what I would like to try to start out with today is using slope-intercept form equation to figure out the missing parts. So right now, if you look at what we know what the x value is, we know what the y value is, and we know what the m value is. Those are the parts that we know from the given information. So if you remember, slope-intercept form is y equals mx plus b. That is what slope-intercept form is. So if we're given specific parts, as you already have been studying for a long, long time, when you're given specific parts and some of them are missing, you know algebraically how to solve for the missing part. And that's exactly what we're going to do today to determine what the equation of the line would be. So the information that we know that the y value is -7. We know that the m value is -3. We know that the x value is 5. But what we're looking for is the y-intercept, where it crosses the y-axis. So we're looking for the b in this situation. So our variable that we're searching for in this situation is the b. So all you have to do is mathematically solve for the b. So we have -7 equals -15 plus b. And now you just simply look at it as using the BU chart. Our variable is b. What are we doing to b? We're adding a -15, right? So in order to get rid of that, we need to do the opposite. So we're going to add 15 to both sides, and we'll be left with b. Okay, so if we take plus 15 on this side, that makes a zero pair. What you do to one side, you have to do to the other. And so we have a zero pair here, which gives us b equals 15 minus 7 is 8. So we now know that the b is 8. So our equation for this line is y equals -3x plus 8. And now that we have that, we can draw it, okay? And so that's kind of the cool thing, is that once you can set up for the missing values that you're seeking, then you can graph it and see if you're right. Now, we can graph it two ways. And the first way that I would like to graph it is I would like to graph with what we know. So I'm going to go back to the original color that I started with, which was green. And it says that the point sits at 5, -7. So I'm going to the right 5 and down 7, which happens to be right here. Then it tells me that the slope is a -3. So I automatically have to think in my brain, since this is a -3, I know the slope of my line is going to look something like this, because that's a negative slope. So what that means is I have to go down 3 and to the right 1, right? Because that would be still a -3 slope. So I have 1, 2, 3, and to the right 1. And now I can go the other direction, up 3, 1, 2, 3, and to the left 1, because that would still give me a negative slope. Up 3, 1, 2, 3, and to the left 1. Up 3, 1, 2, 3, and to the left 1. Up 3, 1, 2, 3, and to the left 1. Up 3, 1, 2, 3, to the left 1. Up 3, 1, 2, 3, to the left 1. So now I have our line that has been connected from the fourth quadrant to the first quadrant to the second quadrant. So it's covered all of the quadrants that we can get on our graph. And now if I connect those lines, or those points, then I would have a straight line. And I don't have my ruler sitting here, but just for time's sake and the lack of having a ruler, our line is going to look something like that if you connected them all in a straight line. Okay, so that's us using the point that it goes through, which was -7, or 5, -7 with a slope of -3. So that's what it looks like using just the information we're given. Now, if we plot it using this equation that we came up with, it says that where it crosses the y-axis should be at +8. So 1, 2, 3, 4, 5, 6, 7, 8. Aha, it did. Check it out. So there's +8. And then our slope says go down 1 and to the right, or go down 3 and to the right 1. So I go 1, 2, 3 to the right. There it is. 1, 2, 3 to the right. There it is. 1, 2, 3 and to the right. There it is. 1, 2, 3 to the right. There it is. 1, 2, 3 to the right. There it is. 1, 2, 3 to the right. There it is. And then if we did this one, 1, 2, 3 and to the right. There it is. And so by applying what we did when we turned it into an equation, both of them match and we come up with the exact same line. So that was kind of powerful. You were able to take some very minimal amount of information and still be able to come up with the equation that graphs correctly from the very limited amount of information that you were given. So going back to what we just accomplished, which pat yourself on the back, that was pretty awesome. When you're given very minimal information, now you have to remember, we were only given a point and we were only given the slope. That's all we were given when we started, the point and the slope. So the first thing that we did is we remembered the equation for slope-intercept form, y equals mx plus b. Then we plugged in the given information. -7 was the y value, 5 was the x value. We were given the slope of -3, and then we solved for the unknown, which was the b, or the y-intercept. So we went ahead and solved that, figured out that the y-intercept was 8, and then we plugged it back into our slope-intercept form, y equals -3 times x plus 8, and that's how we solved that, which was very, very important. And then we graphed with the very minimal amount of information that we had. So we went to the right 5 and down 7, and then we applied our slope of going down 3 and over 1, up 3 and to the left 1, up 3 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 to the left 1. And then we were able to create this line. And that line, from the minimal amount of information that we had, graphed exactly what it turned into when we had it in slope-intercept form. So that's pretty awesome. You guys did an amazing thing in this lesson. Okay, so let's go back to our goal. Today we will learn how to identify a linear equation based on points and on a line. That's exactly what we did. Okay, so that was really kind of cool. One other thing that I want to throw at you very quickly, because I know in class they're probably going to make you do this. If you were given 2 points, and let's say one of the points was 0, 3, and the other point was, let's see, sorry, I'm trying to think in my head. Let's do 1, 5. You were given that, and they told you to create an equation, okay? So if you were only given 2 points and told to create an equation, you still can do the same thing. You just have to add an additional step. And remember, in order to find the slope, you have to do rise over run. And remember, it's the differences in the rises, and the rises are your y values divided by the differences of your x's. Okay, so that's how you find the slope. And so you're going to take 5 minus 3 divided by 1 minus 0, because it's the differences of the y's divided by the differences of the x's. And so 5 minus 3 is 2, 1 minus 0 is 1, and now we have our slope equals 2. And then you have your 2 points. And so you can do the exact same thing we did on the other side, where you're going to take 5 equals 2 times 1 plus b. So we have to figure out where it would cross. And so you're taking 5 equals 2 plus b. You're going to solve for b. Well, you ask yourself right there, you're going to say, what number plus 2 equals 5? And we would get 3. So now we found the b. So now we can write our equation y equals 2x plus 3. And if you were to graph these 2 points on a graph and then connect them together, I guarantee that this is the line that would come out. And that's what you're having to do in this lesson. You're either given 2 points and having to solve for the whole process, or you're given a point and the slope and having to solve the whole process as well. Okay? So today we will learn how to identify the linear equation based on the points on a line, which is what we just did. The question that I wanted you to think about in this lesson is, what must you have to create an accurate equation of a given line? I would say the things that you have to have is you have to have at least 2 points. And if you don't have 2 points, then you have to have 1 point and the slope in order to create an accurate equation that represents the line. So again, what do you have? At least 2 points. If you don't have 2 points, you have to have at least 1 point and the slope. Okay? And that's how we would answer that question. All right, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye!